Hi there, thanks for joining us. This is Space Nuts, where we talk astronomy and space science. And we have a lot to talk about on this episode. My name's Andrew Dunkley, by the way, just in case you've never heard of me. I have not heard of me. My wife actually hasn't heard of me. I walked out the other day and she went, "Who the blazes are you?" And I had to do that introduction just like I did then. Anyway, coming up, I don't know where that came from. We've got a lot of stories to talk about. There's a new paper explaining Venus's strange rotation. And interestingly, I think someone threw a question at us not so long ago about this very possibility. Protocols for announcing evidence of intelligent life beyond Earth have been updated. What's that mean? Well, we've got to prove certain things before we can announce certain things, as it turns out. And a couple of interesting stories about moon dust, using it as a building product, and finding aliens. That's all coming up in this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9, ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And chuckling away in the background at my ineptness is Professor Fred Watson, astronomer at large. Hello, Fred. Is ineptness a word?
I think it's ineptitude.
Yeah, that's the word. I knew it was wrong.
Either way,
it's too early.
It does apply to you either way.
Ooh, snap. I can live with it. I'm tough. 40 years in radio sort of hardens you eventually.
Yeah, I'm sure it would, yes. Yes. Yeah, I'm sure it would.
Yeah. How's Marnie, by the way? She's been a bit off colour.
She has been crook, yes. I think she probably got the same cold as you had a few days ago.
Yeah, well, we're not going to talk about that.
We're not going to talk about it. But she did her, I think I mentioned it already, that she did her 21-kilometre run on the weekend, the half marathon, which she's still recovering from.
I admire people who do that. I do a half a golf course occasionally and come home feeling like death warmed up.
Yeah.
And that's only blundering along very slowly. I'm so lazy now I've got a remote control buggy. Oh, dear, oh dear.
Seriously?
Yeah.
Oh, my God. So it's got wheels and trundles along on its own, does it?
Yeah, I just use a remote control to steer it. I don't push. It's amazing how much energy you use pushing one of those things.
I'm sure it is.
Or not.
But isn't that the whole point of playing golf?
No, I'm still walking. I'm still walking.
Yeah.
I'm just walking without having to push something. Or pull it, or whatever.
Yeah. No, look,
they've become all the rage. It's a poor man's golf buggy, basically.
Yeah, okay.
I can't afford one to drive, so I just
have
I've got one that drives itself.
I haven't seen those. That's really interesting technology.
Yeah, a few brands on the market. They're pretty good these days. Although I've found that on the gravel paths that we've got around the course, it gets more grip. So when you turn left, it sometimes does a U-turn. You've got to be very careful.
Yeah. Yes.
Oh, dear. Okay. Oh, gosh. Enough of that. But, of course, there's remote control buggies all around the solar system. So,
yes, there are.
They're on the moon. They're on Mars.
There are. Yep.
Yeah. I'm probably qualified to drive one, actually. Yeah.
You might be.
Let's get to some more serious topics. And our first one, as I mentioned in the intro, is a paper that's been released about the unusual rotation of Venus. And we did get a question about that very thing recently where someone said, well, couldn't it have been something hitting Venus that caused all these things to happen? In fact, I think they suggested it might have been Thea. But, I think we extinguished that possibility. But this paper is suggesting something big and cataclysmic did happen.
That's correct. So I always have to refer to the expert book on this, which is one I wrote, the kids' book, just to remind us what Venus does. Its year is 224.7 Earth days. And its day is 116.7 Earth days.
That's weird.
Yes, very weird. And it kind of effectively rotates backwards.
Yeah.
So, yes, how did it happen? And I mean, this paper is basically what our listener said. It's basically telling the story.
I think it was Rusty in Donnybrook.
I think it was Rusty too, yes. And I think he also mentioned Thea in that regard. You're quite right. Well done, Rusty. So there is a group there they're led by a scientist at ETH Zurich, which is the university that Einstein went to. And we visited a long time ago, a few years ago, on one of Marley's tours. Anyway, it's always been suspected that what probably happened here is something hit Venus, suggested by Rusty. Some impactor actually clouted Venus, and that's what changed the rotation of the planet, and probably very early in the solar system's history.
Okay, well, that writes off Roger Federer. I really thought that might have been it. He can hit a ball.
Yeah, well, yes, it's always a possibility, but yes, it does write that one off. So it's going basically backwards. What these scientists at ETH Zurich had done is modelled what you'd need to hit Venus to make it look like it does today, and it doesn't just include the rotation. They've kind of fed into it what we think we know about the internal structure of Venus, which is actually not much, but enough, that we can make, I guess, broad projections as to what might have happened. Just a reminder that Venus, of course, about the same size as Earth, surface temperature about 467 degrees Celsius on average, enough to melt lead, as they always say, and also with an atmospheric pressure nearly 100 times that of Earth. Just a hellish place. It's definitely the Earth's ugly sister. We also think
I've never heard that before.
Oh, haven't you? Oh,
no. You probably have said it before, but you know what I'm like.
It's the normal. people talk about it being the Earth's ugly sister. It is too. We think as well that Venus doesn't have plate tectonics, that it's got a crust that is basically continuous, not broken up into moving plates like we have on Earth. And that might be one reason why they've got the runaway greenhouse effect, because the plate tectonics on Earth actually do help to stabilize the carbon dioxide in the atmosphere. It's there's a carbon dioxide cycle, which basically it's almost like a thermostat. And that's why we're so worried about tinkering with it, and since the Industrial Revolution. That's not the revolutions that we're talking about, though, at the moment. We're talking about the revolutions of Venus. So there's a segue for you that I wish I hadn't bothered with. So what's the story? Something possibly moon-sized or bigger. They're talking about an impactor that's a tenth of Venus's mass. Now, the moon's, I think it's an 80th of the Earth's mass, so it's smaller than this, so it would be a bigger object. But if you hit it at a high angle, and I assume that they mean by that a sort of grazing angle, so it's coming in almost horizontally to the surface of Venus, because that will be the impact angle, that will actually have the effect that you might want, which is to slow down very dramatically the rotation of the planet. Now, back in the day, when we're talking about in the infancy of the solar system, remembering that the solar system is about 4.7 billion years old, this was probably within the first few 100 million years. At that time, the planets had much higher rotation speeds than they do now. We think at its maximum, the Earth was rotating about once every 4 hours, which is quite dramatic.
Oh, yeah.
And maybe Venus was the same. So it's done quite a significant job if it slowed it down to this backward motion that we've got today. And that's what they've done. They've modelled, they've modelled the impact and modelled the details, and they can get a result which basically leaves Venus as it is now. But what they also suggest is that you basically melt the surface of the planet as well. You produce what they call surface magma oceans. And we think the Earth went through a phase like this. That might be in the aftermath of the Theia impact, something like that. Mm-hmm. But then they've looked at the extent to which that melted surface can basically lose heat out into space to cool things down and solidify the surface and let Venus settle into something a bit like what it is now. Yeah. Excuse me. So all those have come out from the study. And one of the interesting things as well is that they look at the content of water within.
I was just looking at that.
Yeah. There's a quote from the lead author on this paper. Whether or not the interior of Venus is still wet somehow, whether there's water in the interior, because that makes a huge difference for whatever scenario we can think of for the evolution of the planet. If the interior is dry, it would also be pretty clear that Venus would have lost all its water. But if it's wet inside, then the mystery continues. And by wet, I think they mean the presence of water molecules, probably bonded with the rock, rather than water sloshing down in the middle, sloshing around in the middle, because of course the temperature's very much higher than the boiling point of water.
Of course, we're writing off the Theia possibility, but obviously at that time, very early in the existence of the solar system, there was a lot of junk flying around and a lot of things were hitting everything, basically. I don't think there were too many things that didn't get smashed up at some stage.
Exactly, that's right. It's part of planet formation, getting smashed up.
And I think we're making the same assumption for Neptune, aren't we?
Uranus,
yes. Which seems to have suffered some sort of heavy impact with something big.
Yes.
And that's where we're at. Thankfully, things have calmed down a lot since then.
Yes, they have. And long may that continue.
Still a lot of rocks flying around, but they're getting smaller.
They're getting smaller, and they're sort of concentrated. A lot of them are concentrated in the asteroid belt, of course, and the trans-Neptunian various belts out there as well. Kuiper belt et al.
Yeah. If you'd like to read about that, you can do so at phys.org, PHYS. That paper was presented at the European Geosciences Union General Assembly in Vienna. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
I think we need to do a little more all-weather testing. Amen.
Space Nuts.
Now, Fred, we quite often talk about the search for extraterrestrials, and so far, nothing. But if the day ever comes where we have to make a big announcement to say, hey, guess what? We found little green men, there are protocols that exist, and they've just updated them.
Yes, that's right. That's exactly the story. So, excuse me, these protocols are contained in something called the Declaration of Principles, and these principles are essentially laid down and determined by something called the IAA SETI Committee. Well, we know what SETI means, Search for Extraterrestrial Intelligence. IAA is the International Academy of Astronautics. I guess it's a bit like the IAU, the International Astronomical Union. It's a kind of governing body which ratifies these declarations of principles. Now, it's something like 16 years, excuse me, since the I've got your frog in the throat here.
Yeah, sorry about that.
It's 16 years since the last revision of these declarations of principles, and a lot has changed since then. The committee that looked at this was led by an astronomer at the University of Manchester, Professor Michael Garrett, and he has said some things that really put this revision into context. So I might just quote him because it basically sets out why this has all happened very neatly. The information environment that we operate in today is vastly more complex than it was in 2010. In an era of deepfakes, automated misinformation, and instant global connectivity, a single unverified claim could trigger confusion or panic. These new protocols ensure that scientists maintain the highest standards of evidence before making announcements to the world.
Yep.
And that's because, an announcement would really be quite extraordinary. It would be, as one commentator writes, it would be a transformative moment for humanity.
It's ironic that should be how they describe it, because not blowing my own trumpet here, but in the sci-fi trilogy I've just finished, that's how the whole story starts.
With a transformative moment.
Yes.
Yes.
Yes,
yeah,
exactly. And based on that kind of protocol that we're talking about.
Oh, okay. Well, I hope your trilogy is up to date with the latest protocols.
It is, believe it or not.
Yeah. So there's another comment from the SETI Institute president. SETI Institute does exist. Bill Diamond, he's another member of the committee. He says the release of these updated rules and protocols marks an important step in acknowledging both the radically different media landscape that science functions within today and the vastly expanded efforts in terms of technology and resources being deployed in the search for intelligent life beyond Earth, which are we're looking everywhere, basically, on Mars, on the exoplanets of other stars. All of that sort of stuff is very much the stock in trade of what astronomy and space science do today. So he's absolutely right in that.
Well, we've seen some false alarms in the past. There was that rock that we found back in the Clinton administration that they said, there was life on Mars.
That's correct.
Turns out it wasn't.
Yeah, it's probably just, chemical artifacts. And the perhaps the most recent one was the, I forgot what the chemical was. Was it phosphine or something? I can't remember.
I think it was in Venus's atmosphere.
Venus's atmosphere, that's right. And that certainly stirred the bones of everybody interested in life beyond Earth. Yeah. But neither of those, of course, were intelligent life.
No.
They were false alarms for basically microbial life. The intelligent life is a different one. It's one where you're responding to some sort of either an artifact or a signal. We might even discuss some of this in a little bit more detail in a minute, because we've got another story that relates to it.
Yes, we do.
But it's all about the finding of some species that operates essentially the same way as we do. And I think the bottom line in all this is extraordinary claims need extraordinary evidence. That's the bottom line.
Yeah.
There is a nice quote here from there's an article by Stephen Cooper in Space Connect, which is a website. Which says the new framework also addresses challenges that would have been difficult to anticipate when previous protocols were drafted. It includes provisions to protect researchers from harassment, doxing, and intense media pressure in the event of a credible detection, and establishes clear procedures for distinguishing verified data from hoaxes or interference from terrestrial sources. So that's really the crucial part of this. It's all about bringing it into the 21st century, in the era that we live in today.
Yeah, it's so hard to filter out the rubbish these days, particularly on social media, where clickbait is basically running amok. I've seen some things in recent times that just really make me angry. I think there was a story recently about a volcano in Japan that has become quite active and has been erupting. And I was reading the story, but the video footage was completely AI, showing the volcano at ground level obliterating a town. Now, it was absolute rubbish, total rubbish.
Wow.
But people fall for it.
Yeah. Yeah, that's right, and yes, exactly true. And you've got conspiracy theories being built up from that because people believe what they see and believe that the mainstream is hiding stuff from them.
Mm. Yeah.
I still talk to people who ask me about Roswell because they think there's something the hidden is hidden there.
Yeah, It's unfortunate, but I think they did I read an article the other day that suggests that 33% of people honestly believe that aliens are already walking amongst us on Earth.
Yeah. Yes, that's right.
So, it's... And social media is probably making that worse.
Yeah, that's
just to finish this story off. I think the line that says it all in this article on spaceconnectonline.com is no public announcement can be made until a signal or artifact has been rigorously authenticated by independent organizations using different instrumentation. That's the bottom line with this whole approach.
Yeah.
The protocols have been updated and you can't go public unless you have got multiple sources with different authentication methods. So
that's right. Just one more footnote, if I may,
yes,
Andrew. Again, I'm reading from that Space Connect article, but it's an important point. On the question of responding to any detected signal, the declaration is unambiguous. No reply should be sent. The declaration reaffirms that transmitting a response to an extraterrestrial intelligence is a decision belonging to all of humanity, one that should only occur following international consultations conducted through the United Nations. So
isn't that interesting?
Big thing as well, yes.
Because in my story, that was the decision. We're not going to answer this.
Yes, yeah. Well, you're on the right track there.
Yes.
You're following the mainstream.
I could have written this paper. Yes,
Yeah, you could.
Indeed. Probably not. But if you'd like to read all about it, as we said, spaceconnectonline.com. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Space Nuts.
Now, Fred, we've got a couple of stories that are related to moon dust, and one of them correlates with what we were just saying about the finding of extraterrestrial intelligent life. And one of the ways they think we might be able to find historical evidence of intelligent life is to look at moon dust. This is a bit weird and out there, isn't it?
It is, but it makes complete sense what these authors are saying, and it's actually it's a single author, actually, Brian Lackey, Lacki, who's in Oxford in the UK. But basically, the premise of this paper is that you've got a universe that's 13.8 billion years old. We've had what you might call a technological civilization for perhaps 400 years. So what he's arguing is that the chances of overlaps in time between civilizations are very, very small. And you're not going to find, unless it's by complete chance, you're not going to find a civilization which has evolved or emerged to the same level as we are here on our planet at the same time. The odds are that they're either in the past or they're in the future.
Yeah, and I think you've said several times that if we do find anything, they may well have been extinct for thousands of years.
Yes, or even millions of years.
Or millions, yeah.
So that's his starting point. And so what Dr. Lackey says is that what we're more likely to find are the wreckage or, the ruins or the artifacts, leftovers from a dead civilization.
The peas that the kids wouldn't eat.
Yeah. Yeah.
No.
Or the bits that have fallen to pieces.
Yes.
And in particular, what he looks at is something we've talked about before, Dyson Dyson swarms or Dyson spheres. Dyson spheres are, the idea is that you build a spherical shell around a star to collect all its energy and turn it into power, because you're such a power-hungry civilization. I think later research has shown that Dyson spheres can't exist. They just break up because they're gravitationally unstable. So it would be more likely to be a swarm of satellites.
But they are talking about harvesting power and transmitting it to Earth from the moon and things like that.
Yes, indeed, and from space. And we've got Elon Musk's idea of, in fact, it's not his idea. There's several companies, but his is the most advanced, perhaps. 1 million satellites collecting solar power to power data centers.
Yes.
It's an idea that horrifies all of us in the astronomy world. 1 million satellites is just unthinkable, but never mind. We're not talking about that today. We'll talk about the dead civilizations. So, you've got large structures in space, megastructures, we call them, which would basically eventually, over millions of years, would collapse or break up, perhaps be broken up into small pieces by micrometeorites. But they would linger in space. They wouldn't just be destroyed. They'd become part of what we call the interstellar medium, the gas and dust that sits between the stars. And of course, the Earth and the Sun and the whole solar system are actually moving through the interstellar medium. So what he's suggesting is that you need something solid that might collect these fragments, but isn't being disturbed in other ways. Because it doesn't have weather, or it's a kind of totally inert surface, and the surface that he points to is, as you've suggested, the surface of the moon. What he's saying is that maybe among the regolith of the moon, the soil of the moon, there might be evidence of past civilizations. So if the particles are small enough, they can actually be blown along by the solar wind from their own star, the star that they started off from. But I guess what he's thinking of here is very small dust particles in amongst the natural dust particles of the lunar surface that basically differ from the natural soil of the moon. And he gives them a name. He calls them technograins. Technograins are grains of dust that actually come from technology. Now, what you've got to figure out is how they differ from natural grains of dust. And I guess what he is thinking of is the chemistry of them. I haven't actually looked in detail at his paper, but it's basically suggesting that if you screen moon dust and look for signatures of extinct megastructures, then you might find them in some way. It would be very much a dust that would have to have some absolutely rock solid evidence of having had an artificial source.
Yeah,
but that might be possible. There are chemicals that don't occur in nature that they might find their way into one of these things.
I think the hard part though would be finding it first, because I would imagine by the time it finally hit the moon, it'd be fairly sparse. Like it wouldn't be a big cluster of dust particles. There might be one or two dust particles by the time it got here.
Exactly. No, I agree with that. I think that his comment is simply that it might be there. So should we be, getting a sieve and putting moon dust through it and looking for anything interesting that's left behind, like a screw or something like that? That would be good enough, actually.
Yeah, that would do it.
That would do it, as long as you weren't near one of the sites where something's collided from Earth, because there are several places on the moon where spacecraft have landed in one of these unanticipated, what is it he calls them, unanticipated dismantling, or I can't remember Elon's term for when a spacecraft blows up.
Yeah. It's an interesting one. And look, you never know. Maybe there are past civilizations floating around out there, the remnants of, and we could have passed through that dust and yeah. So maybe one day someone will have time to go around the surface of the moon with a sieve and see what they can find. I think they found a Coke can on the moon, on Mars once, but it was only that pareidolia effect.
Yeah, pareidolia.
Wouldn't that
it
be
does
funny?
have, just thinking about it though, it does have echoes, doesn't it, of 2001: A Space Odyssey, because the monolith was on the moon.
Yes, that's right.
And magnetic anomaly.
And quite fascinating. If you'd like to read that story, it's at phys.org. The paper was published on the archive server by astrophysicist Brian C. Lackey. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Space Nuts.
Staying on the moon, Fred, this one is also focusing on moon dust, not to find past civilizations that might be floating around out there extinct. This has got more to do with long-term accommodation and other infrastructure on the moon. And of course, the big problem is getting all the stuff up there to build your condominium or whatever it is you're going to do. There might be an alternative.
There might, that's right.
It's called moon dust.
Yes, indeed. And so this is some work that's come out of Texas A&M University. And it's actually, I think it's civil engineers who've written this paper rather than astrophysicists about exactly as you've said, about how you take, if you're going to have a moon base, and that's certainly on the cards. I mean, NASA's talking about a permanent presence on the moon by 2040, which means fairly sophisticated equipment and accommodation. If you're going to have that, you've got to look at the practicalities of basically how you get it there. There's a really nice quote actually from this Texas A&M professor. He's a professor of construction science at the College of Architecture. His name is Dr. Patrick Surman, Suerman. Put a P in it and it makes Superman. He says, we're moving past the era of flags and footprints. We have to stop thinking like explorers and start thinking like settlers. That means building with what's underneath our boots. And so there was a space conference, I think quite recently at Texas A&M, and he essentially presented his vision of how this should be done. And the starting point is this quite staggering statistic, Andrew. This blew me away. It costs roughly $1 million to $1.3 million per kilogram to ship materials to the moon.
Yeah.
So that's the starting point.
That's an expensive condominium for sure.
It certainly is, yeah.
I like the concept. I suppose the difficult part is, the raw materials are there, but how do you go about using it and creating the building products and the hardware you need? What would the process be?
So it's difficult stuff as well. Moon dust is very, very fine. It's very, very spiky.
It's like talcum powder. According to Buzz Aldrin.
That's right, with spikes on it. It's got very sharp corners, unlike talcum powder, which is why it sticks to everything. So, as you know, it stuck to the spacesuits of pretty well all the Apollo astronauts who walked on the moon, and one of them got hay fever from the dust on the way back.
I didn't know that.
The first case of lunar hay fever.
Wow.
I can't remember who it was, but it was one of the returning Apollo astronauts. Anyway, the moon dust is there. And so that's the fundamental basis of this paper or this work. How do you turn something like that into something that you can work with? Bricks and mortar.
Harrison Schmitt, it was.
Oh, it's Harrison Schmitt. There you go.
Apollo 17.
It's Apollo 17, the final lunar landing mission. So it's basically what they've done is they've set out the the paradigm for using moon dust as a building material as they see it. And it's not going to be as this article, which is on the brighter side. Actually, it's one of those rather jolly websites relating to many aspects of science. The first real lunar work crews, instead of teams of builders in hard hats, might depend on rovers moving the regolith and robotic arms printing structures layer by layer. So 3D printing could come into its own using moon dust as the raw material.
Wow, we've got 3D printed toilets in Dubbo.
Have you now?
Yeah, they built them in the park over on the western side of the river a few years ago. I remember watching every time we drive past, you could see the machine sort of adding another layer to the structure.
There you go. I mean, if you can print a toilet, that's certainly the most important part of any building that you're going to put together. That's right. There you go.
Can be done.
And just one final comment on this. This comes from, as I said, Texas A&M, and certainly for Dr. Suerman, apparently, well, it is, as the article says, before arriving at Texas A&M in 2017, he spent 2 decades in the U.S. Air Force, building sustainable infrastructure and bases in remote locations, including Guam and Greenland. There's 2 places that is hardly more different.
Oh, yeah.
Those years, he said, shaped the way he thinks about construction under pressure. So it's, I think it's a really interesting. Perhaps look into the future. Maybe by the time we get old and grey and Space Nuts is really creaking around the edges, we might be talking about 3D printed buildings on the moon.
Maybe. Yeah, it is fascinating. Yes, he laid out his vision at the 2026 Earth and Space Conference at Texas A&M. You can read the story on the brighterside.news website. I think that brings us to the end. Fred, thank you very much.
Thank you, Andrew. It's been jolly to talk about all this stuff. It's been a very brighter side morning.
Fascinating stories they are. And yes, so we will catch you up very, very soon, Fred. Thank you again.
Sounds great.
Professor Fred Watson, astronomer at large. In the meantime, if you'd like to visit our website, it is online all the time, never breaks down. It was 3D printed at spacenutspodcast.com or spacenuts.io, and you can have a look around there, send us messages or questions. You can visit the shop. You can look at the Astronomy Daily newsfeed, sign up for that. You can become a supporter, whatever you like. That's at our website. Thanks to Hugh in the studio. He couldn't be with us today. He's always looking for the next big thing, and he told me he's running off to start a company called Moon Dust Brick and Tile. So we'll wish him well with that. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.